Sir, topic simulation performance evaluation of ad hoc network protocol with quality of services. Are you ready, sir? Davande, sir?
Yes, ma'am. Okay. So first I brief about my work that I'm going to present. So this is related a network, innovative network which is consisting of nodes, transmitting and receiving nodes, and which I project to replace our existing mobile communication because of the problems of the radiation from the mobile towers. So in this, I am trying to use the protocols which will replace the mobile communication with the node-based communication where we don't need the centralized towers, but we need only the communication, cooperative communication between the mobile phones. So these mobile phones will relay the signal from one to other, and in that way, this will be the ad hoc kind of a communication which will replace the transmitters. So I'm going to cover the following points. So which consider objectives, methodology, results, and conclusion, future scope as usual. So here we can communicate by using a router with the multiple computers. So this is just like our mobile communication where there is a centralized tower and subscriber mobiles. So in this network, as you see on the right side, we don't have any centralized infrastructure, but we are having these nodes which are communicating with each other, and they are helping each other to send a signal from one means the source node to the destination node. So these nodes are having limited range, and even if they are not in the range of each other, they can communicate with each other by in which the intermediate nodes will relay the signal from one place to other place. So this is the theme behind this work. So main thing for the ad hoc, if you are setting up the ad hoc network, just like what I told, where it is not pre-planned, means the mobiles in a building are helping each other to communicate. So generally, if you compare this with the wireless sensor network, where the battery is the issue, then since the size of that nodes are less, that's why there is a bandwidth is the issue, and topology is obviously very uncertain. So in that case, we want to communicate, and here I am trying to target to replace the existing mobile system with this ad hoc system. So the bandwidth is very much important because you know that data is the main thing that is required. Means everyone is trying to increase the bandwidth so that the signals, not only the voice signal but also video signal, can be transmitted. So I am targeting this bandwidth as a main parameter, which will means one step ahead towards using this ad hoc network instead of the our infrastructure based mobile communication. So for this purpose, I just enter into the routing model because this is a routing that is required. Routing means whenever the source node want to transmit the signal to the destination node, then in that case the route should be already present, or secondly, the route can be created whenever there is a requirement of the transmission, or combination of these two. So the constraint of the wireless mobile ad hoc network are they are having a channel which is uncertain as usual. Then the nodes are moving, so that's why topology is not certain. We don't know when the source node goes out of the range of the destination node, and that's why we don't know when the intermediate node needs to take part in the transmission. And we need to go for a robust routing system in which we have to maintain the means routing tables which will record the information about the presence of surrounding nodes, so that they Using this information, it is possible to create the route between the source and destination node through these intermediate nodes. And limited bandwidth and the energy constraints are there, which we have to take care. So one of the main thing that is required here, that can be coined as a word QoS, quality of service, because whatever may be the situation, whatever may be the constraint these networks are having, but the target should be they should provide the quality of service. Excuse me. Means when the communication is established, it should remain for a long time. Then there should be delay. There should be less delay. That is, we have to control the latency. Then we have to minimize the network congestion, because we have to decide that whenever there is communication taking place, the other nodes, even if they want to transmit, they have to stop and wait until the channel is free for them. So this creates a latency. Excuse me. So we have to go for the traffic flow. We have to maintain the traffic flow. That also important. Not traffic flow between the moving networks, but traffic flow of the communication that is taking place between them. And we have to set up the priority for the communication, because here also we'll have to categorize the nodes in terms of their priority. Means some nodes may be having, or we have to assign a higher priority, so that service we have to take into account. So this is very challenging. At the first stage, it is challenging to maintain the communication, and second thing is to maintain the communication with quality. So that's why there are so many parameters that we have to consider, that we have to consider the traffic rate, speed of the nodes, pause time of the mobile nodes. So all these things we have to consider, and which will determine the quality of service. And depending upon this parameter, we can say that yes, this is the quality we can provide for this given situation. If the modes are moving too fast, the quality cannot be guaranteed. That is okay. So we have to optimize the quality, that is quality of service. That is my main objective of this research, and with respect to the speed of the node and other considerations. So for this purpose, there are so many protocols available to take the challenge of this communication, and there are different types of protocol, just like DSR, AODV, DSDV. So I choose the AODV protocol because it is most suitable protocol for this communication, this type of communication, and it is on-demand protocol, because whenever there is a need of communication, then the protocol will activate, and this will save a lot of overhead, because for maintaining the proper bandwidth or efficient utilization of the bandwidth, we need to use the bandwidth more carefully. So the AODV, as already known, it is based on the different messages, that is route request, route reply, route error, and hello message, which is useful for telling that yes, I am here to other nodes. Now this is a kind of a I'm just trying to explain how the A is being communicating with the B by means of, or by the help of the intermediate nodes. Okay. So first of all, B sends the message to A through these nodes. Oh, there is some. Okay, we'll move ahead. Because of the constraint, I'm not able to show that complete steps. Okay. So here I'm targeting mainly on the AODV message type, because I want to, I'm focusing on the bandwidth, and for focusing bandwidth, I need to change this message. So these messages I try to change, but let us see how this message works. When, as you can see here, there is a source and there is a destination, and source want to transmit the signal to the destination. So a lot of messages are there. It starts with the route request. This message is sent all over the network, and whenever, depending upon the routing table, each node will respond to that. and if that routing table or the node finds, for example, B node finds that there is a path from A to D, A to D, and it will send, it will forward the request, and D will forward the request, and ultimately the RA reaches to the destination node. In this way, the communication starts. And when the communication link is established, the root reply message is sent back to the destination node to the source node. So in this way, the things work. And depending upon the position of the intermediate nodes, these um, root request and reply message will go in the different paths. So you have to also handle the congestion, and due to short of time, I cannot explain much about that right now, because we have to cover many points. So that's why I have I'm, as you can see here, I am targeting the AODV routing. Okay. So for this AODV routing, we have to first discover the route. As I told that this message RREQ will send the request message and to find the route, and intermediate node will check the presence of the path which can lead to the destination node, and they will forward the request accordingly. So then not only it is necessary to discover the route, but we have to maintain the route, because these nodes are mobile. That's why they may move from one place to other place. And within, when the communication is taking place, within that period also the nodes are moving. So the hello message is required in between to tell everybody that I am here, so that if the route breaks, everyone knows that which node is where, because otherwise there is no way for this node to know the position of the fellow nodes. They are moving constantly, so their position is recorded by means of this hello message. And when the links are broken, excuse me, for when the links are broken, then we have to re-establish the route by again sending the route request message. So this is a very complicated process, and this required a robust protocol, and I'm trying to take care of that. But my contribution is related to bandwidth, because this is just a comparison of the different protocols that you can see here. But this is the main thing, that what I am doing, that since my target is to use the existing ad hoc network, which are mainly the wireless sensor network, as a modern way of communicating, and replacing the existing infrastructure based mobile communication, where they don't need any centralized tower. And here the cooperative communication is taking place. So main target of this research will be to provide the quality of service, because for the customer based mobile communication you have to satisfy customer also, because nowadays data traffic has increased, and that's why it is essential to provide more and more bandwidth. So that's why my target is the bandwidth, and that's why I decided to include one more field in this header message, in the header of this message, which is the bandwidth required. So the message itself will send that I want this much bandwidth, and depending upon that, means the routing process will go ahead, and the protocol will take care, and further processes steps will taken accordingly. So here I'm targeting some, that's why I've gone for some simulation and simulation based research, where I'm using NH2 for this, and here I'm targeting some performance parameter, because I have to evaluate that whenever this communication takes place, what exactly is happening, how many packets are reaching to the destination. Okay, so for that purpose I need to target some parameters, decide some parameters, and these are those parameters, that is average packet delay, packet delivery ratio, throughput, network overhead load. So I'll just tell shortly about that. So whenever packet transmit from one place to other place, how much delay required, that is packet delay. Packet delivery means if I send 100 packets, out of that 50 packets successfully reach to the destination, then packet delivery ratio is 50%. Throughput means how much data was transferred during that particular period of time in terms of communication. And apart from the message, we need a lot of other data also, just like a header. So header, and also we require this message RREQ, RERR, or some other message which are not the part of data, but we have to send them anyhow. So these are overload. We can say that overheads on these communications. So we have to also take care of that. Okay. So in that way, I have gone for this methodology, and I have set up the parameter for this simulation where I use different nodes, then propagation method, then protocol, then uh, queue type. Queue means the queue that is created um, at the out, outside gate, or we can say exit gate of the packets, that is called as queue, and their probability and priority, all other things. So then protocol, then total dimension, and how much time I will continue simulation. Okay, so I use the platform Fedora for this, and I use NS2 network animation tool and GNU plot for the plotting this signal, plotting these results. So I got this type of results. So I got the packet delivery ratio versus average packet delay. Then I have gone for the packet delay versus the speed of nodes. So just I try to find out that what exactly we have to obtain. So these two simulations, one is related to the existing protocol, that is your AODV, and another one in which I added the bandwidth as an estimation field. So the difference between that I try to get. Okay, so where green is corresponding to the QAODV, and red is corresponding to the AODV. Okay, so in this way, you can see that here I'm getting better performance in terms of the parameters by, because this green graph you can see is lesser as compared to this. So everything related to the packet delivery ratio, all this is reduced. Okay, so this I also use the other parameters, same thing I try to see in the different perspective. So due to shortage of time I cannot explain each and everything, but ultimately what I found that due to the addition of the bandwidth required field, I got better performance for this protocol, that is QAODV. Instead of AODV, I am targeting this QAODV protocol. Okay. So these are other things that I try to compare in terms of this QAODV and AODV, and a lot of results are there. So ultimately, I reach to the conclusion that I got a increased PDR, packet delivery ratio, increased throughput, and decrease in average packet delay. So delay was reduced, means this is one step towards the commercial based communication, where you don't, your might be there is situation that president of or some high dignitary is calling to other person, other dignitary in the building, and your phone is helping them to communicate with each other. So this type of scenario can be there if you are using this ad hoc network based communication, but it required definitely a lot of things to go ahead, because a lot of things to be achieved, but this is a tiny step towards that final achievement, because a lot of people are dying out of cancer. Nowadays you see that a lot of buildings rooftop there are antennas, but these people, innocent people, don't know that how hazardous that is for them. The mobile companies are giving 1 lakh rupees, 2 lakh rupees per month rent for the towers, but they don't know how precious their life is, which is being affected. And not only these dwellers of the buildings are affected, but the surrounding people are also affected. So this is the thing which is not addressed. So I'm trying to address that. I We don't want these towers, so we should develop the technology so that we don't need them. Okay, so with that and there is a lot of scope, because you can see that this is the first step, and also why not, we can also go for the nanoscale ad hoc networks, where it can have a different application in a different domain. So this can be gone to the nanoscale, because I know that there are a lot of steps to be taken for achieving the real-time commercial based quality of service. But definitely not in that way, but in the nanoscale, we can go for this communication, and definitely it will help, because I think that a lot of scope is there in that, because I've done MS from USA. Yes, sir. Concluded. So any questions, sir, please?
Any
Uh,
question?
you are using NH2 platform for simulation, right?
Yes.
In the results you have shown, how many nodes you have taken for simulation?
50 nodes.
50 nodes. Have you tried with the different numbers of node by increasing the traffic, or only for
Yeah,
50 simulated?
no, this is the one demonstration of the work that I've done. But really speaking, I'm interested in NS3, because NS2 is now older simulator,
Yeah.
and I don't want to go ahead in terms of that, because if you really want to achieve the targeted result, so you must go for something new, which is taking you toward the reality, because NS3 simulator has a lot of added feature. It has
Yeah.
Python front
Yeah,
end,
of course, of course.
and
So
I just
NH3 will be
decided
better.
to stop.
NH3 is better,
NS3
but
will
my
better because
question is, have you tried for more number of nodes or only 50? Because you are saying that you want to reduce the traffic also. So you should try your results for different of number of nodes for simulation. So probably your performance parameter may vary, like delays or throughput. If you increase the traffic, or if you take the more number of simulation node, might you will get different nodes. Okay, so only one protocol you are taking AODV in the to compare, or to for comparison of your QAODV. Only one you are doing.
yes, only one, because I want to focus on that, and I want to go for betterment of that, because AODV is a protocol which is generally used for the wireless sensor networks. So since
Uh,
this network is derived exactly from that, and the constraints are similar, because mobile phones also having the constraint of the battery, isn't it? They are also moving. So a lot of constraints are similar to that. That's why I'm gone for the AODV
is it
protocol.
the part of your research work, PhD?
Yes, yes, it's a part of research work.
Okay, so what
And
it's not
I'm
right
planning to
we
go
have to
for the
do.
further simulation.
Yeah, along with that, I would again like to suggest you shall focus on all the different protocols that are used in WSN. So probably you
Okay,
will
ma'am.
see some change in this. So this was my
Mhm.
suggestion simply to you.
No, definitely. Definitely it's a good suggestion, because I also think that if you go for the cross protocol level rather than going for the single protocol and its detail, so might be I will get some other results, and I may have some decision about that. Okay, it is better to go for that protocol instead of this. Yeah, I just presented the work I'm doing right now, and as you suggested, definitely go for increasing the number of nodes and other things.
Sure, it's nice work, but initially you told that you want to replace the entire transmitter. So that is, I think, the challenging task. We have to prove it in the results. Okay, that's
Yes,
all. That's all from
more
my
number of
side.
nodes required. Yes, ma'am. Yes, ma'am. Definitely.
Any other question? Yes.
No, it was a very good presentation, and I hope you will cover the protocols, etc. What Dr. Gayatri ma'am just mentioned. Other than that, it was quite informative and a nice presentation. Keep it up and
Oh,
continue your good work.
thank you, sir, for your compliments. Thank you.
Thank you very much, sir, for sharing your knowledge and idea with us. Thank you.
Thank you, ma'am.